Let's say two classes both have the same average test score, but one class has scores all over the place. So which class actually performed better? Today, we'll learn how to measure consistency using range, variance, and standard deviation. The mean, median, and mode each describe the center of the data, a single representative value for the whole data set. But they say nothing about how spread out the data is. Two data sets can share the same average yet look completely different. That's where range, variance, and standard deviation come in. They measure consistency. The first measure of variation that we'll look at today is the range. It's the fastest to measure because the range is the difference between the highest and the lowest values in a data set. So for instance, let's say we have test scores and our data is 70, 75, 80, 85, and 100. The maximum value here is 100 and the minimum is 70. So our range will be 100 minus 70, which equals 30. The range is quick, but it only uses two numbers. So one extreme value can completely change it. The second measure of variation that we'll look at today is the population variance. That is the spread from the mean. The variance measures how far each value is from the mean on average. Each distance is squared before averaging. So for the population variance, we use sigma squared, and that will be equal to the sum of each value x minus mu, that is our population mean, squared, divided by n, where n is the total number of values. Squaring the distance gives more weight to values that are far from the mean, which is why outliers matter a lot in variance. Let's see how this applies. We have the same test scores, 70, 75, 80, 85, and 100, and our mean is 82. For each value in our dataset, we'll calculate the difference from the mean. So 70 minus 82 is negative 12, 75 minus 82 is negative 7, 80 minus 82 is negative 2, 85 minus 82 is 3, and 100 minus 82 is 18. So for each difference from the mean, we'll square that. So negative 12 is 144, negative 7 squared is 49, negative 2 squared is 4, 3 squared is 9, and 18 squared is 324. Now we'll sum all of these values, and finally we'll divide by 5, which are our total number of values in this data set. So the sum of the squared distances is 530, and the variance will therefore be 530 divided by 5, which is 106. The third measure of variation that we'll look at is the standard deviation. This one is easier to interpret because the standard deviation is simply the square root of the variance, but it uses the same units as the original data. So the symbol for it will be sigma, which is the square root of sigma squared. For my example, our variance was 106. Therefore, the square root of 106 is approximately 10.3. So think of it as the average distance of each data point from the mean. It's intuitive and directly comparable to your data. So for instance, in this case, the average distance from each test score from the mean of 82 is approximately 10.3. Here's a real-life example. Imagine two investments with the same average return. Investment A is stable. It has low standard deviation. The returns are consistent and predictable year over year. Whereas investment B is unpredictable. It has a high standard deviation. The returns swing widely. It has the same average, but there's far more risk involved. Which one would you trust more? The standard deviation reveals the answer instantly. So here's a quick recap. The range is a quick snapshot of the spread. It's easy to calculate, but least reliable because it's sensitive to extreme values. The variance is the average of square distances from the mean. It's a detailed measure. Outliers carry extra weight though due to squaring. And the standard deviation is the square root of the variance. It's the most practical measure. It uses the same units as the original data, and it's the easiest to interpret. Now you don't just know the average, you know how consistent the data is. Thanks for watching. Please like and subscribe to keep learning with us. And don't forget, math success starts when you stay on the fast track.